Hello guys, this is Vamsi here at Insane Physics, and in today's video we will be starting with basic mathematics, and this is the start of the AGNI series for NEET 2024. Yeah, this is the first episode of AGNI series, and in today's episode or in today's video we will be starting basic mathematics, which will be required, which you will be requiring for the further chapters also in physics. Without these basic mathematics, without this simple basic concepts like differentiation, integration, the so-called trigonometry, algebraic expressions, we cannot do the physics very simply. The physics is so easy once you learn these basic things. These small things only make a large difference in getting marks. And also physics is so easy that you simply have to learn the base formula for every chapter. For example, if you take the Newton's laws of motion, we have four laws of motion, and from that we generally divide and derive the other equations also. Like if you take motion under gravity, we put g in place of a, s h in place of s, etc., etc. So like that, you have to derive everything. That will make your physics so easy, rather than by hearting all the formulas, sitting and by hearting all the formulas from top to bottom in that lesson. You generally do is by heart the base formula for every lesson and try to derive on yourself. For example, I'm just giving you, this is an introduction class, so I wanted to give you a little introduction how this program is going to run. Okay, welcome. This is your Agni series. Agni series for all the aspiring students of NEET 2024. Agni series NEET 2024. Okay, I'm just giving you the base introduction for the physics, not much. Let me just give you an example. How can you derive the formulas? For example, if you take the ideal gas equation. What is the ideal gas equation? Ideal gas equation, it is also for 25, also need 2025, no problem. The ideal gas equation, what is the ideal gas equation? Yeah, we all know that PV is equals to nRT. Now you have to take this PV is equals to nRT, you have to take this PV is equals to nRT and derive many formulas on your own. You can put number of moles as given mass by molecular mass. Yeah, you can include the Boltzmann constant Kb. Yeah, so like that you can put mass in place of mass, you can put density and volume. In place of given mass, you can write density and volume. Like that you will be able to derive some 6 to 7 equations from this single PV is equals to nRT. We all know PV is equals to nRT, but when we try to derive the all the equations which are much possible, you can just simply nail the physics. Simply you can nail the physics, and this physics is so easy. Believe me, it is so easy once you have learned this basic mathematics and also you learn this deriving. On this channel, I will be telling you the basic formula and I will be deriving 2 to 3 formulas from that, 2 to 3 equations from that, and I will ask you to derive many more till 6. 6 is enough. 6 is a very good count. And when you start deriving, somebody thinks that deriving takes time. Deriving takes time. Believe me, believe me. Once you have read the question, once you read the question first time, you will be understanding what are the terms which are given in the question. Okay, you'll be understanding the terms which are given in the question, and you'll able to recognize the following terms, like if they have given mass, if they have given density, if they are asking volume, you'll be able to recognize these terms. And when you start thinking about it, you'll be getting density is equals to mass by volume. Yeah, density is equals to mass by volume. 1 minute, this light is so distracting, I'll be just moving it aside from the screen. Yeah, I hope there is no disturbance in the camera position. I hope. 1 minute, let me just check it. Or if there is some disturbance, no, it is very clear. Yeah. So you'll be trying to think it. Mass is given, the volume is given, sorry, density is given, and you're asked to find volume. So like that, you'll be coming to know what are the terms which are given in this question. And when you start working on it from the base formula, PV is equals to nRT, and you start deriving it, once, initial days it may take time. Initial days it may take some 10 minutes to derive all the six. 10 minutes to derive all the six, provided you know this basic formulas like density is equals to mass by volume, number of moles is equals to the given mass by molecular mass. You know how to calculate the molecular mass if a compound is given, and you know how to what is this R, what is this R, universal gas constant, what is the value of R, 8.314, you have to know what is T, you have to know which unit to put. So if you know these basics, if you are strong enough in these basic formulas, you can derive, first it might take 10 minutes, next it will be taking only 5 minutes, at the end you will be arriving at 2 minutes in order to derive all the 6 to 7 formulas. And when you continuously practice, this, practice, and when you practice, finally you will be able to remember these formulas in your brain. Okay, and you'll be knowing at which step to stop the deriving formula, at which step to stop. So if I go on putting these steps, if I go on putting, if I go on deriving, and my answer simply lies when I change this n to given weight by molecular weight. When my answer comes there itself, there is no point in deriving to until the last. You will not waste your time. So it is very simple. Physics is very simple. Learn the base formula and try to make it very simple. Okay. Please do not worry about physics. I am with you. Let's keep working on. So let us start our AGNI series and the first lecture. Let us start with very full Josh. Let us start with full Josh with the basic mathematics part. Put the heading. The main heading is mathematics. The main heading goes basic mathematics. Okay, mathematics. Sorry, EHEMETIS. Basic mathematics. Okay, I'll be writing it again. Okay, clear. Are we good to go? Are we good to go? In today's video, we'll be discussing about the very first concept of basic mathematics, that is your differentiation. Differentiation and integration, see, they are very easy to do. They are very easy to do when you know when to do them. What are they actually? They're very easy. You'll be having in differentiation, you'll be having some 11 basic formulas. That also you'll be just remembering in your brain. And integration, you have some 5 to 6 formulas. If you just, believe me, if you just make some effort to remember these 11 plus 5 to 6 formulas, you'll be having a good command on integration and differentiation. That would help in any chapter of physics. Without differentiation and without integration, there will not be a question. One question is compulsory based on differentiation, or one question based on integration. So we'll be starting. This two comes under the part of very part of maths called as calculus. 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 This calculus, it is a science or branch of mathematics which deals with changes. Deals with changes. Very simple. In physics, we deal with the two types of changes, two kinds of changes. What are they? What are they? I hope this color is visible to you. Okay. If you want the lecture notes, please mention in the comment section below. I'll be trying to upload this lecture notes also to you. Okay. We generally deal with two types of changes. Okay, let me just change the color to this here. Two types of changes in physics. Okay, we generally deal with two types of changes in physics. What are they? Very first one, it is small changes, and the very next one is your big changes. Okay, we deal with these two changes basically. Okay, we do deal with these two changes basically. Now, what are small changes? What are big changes? Small changes are used for instantaneous values. Instant. At that particular instant of time, what is the speed of the car? At that particular instant of time, what is the acceleration of the car? At that particular instant of time, what is the time taken by the car in order to travel some distance? So those instantaneous, all instantaneous values come under these small changes, instantaneous, and this deals with the average values. What is the average speed of the car throughout its journey? What is the average time taken by the car in order to cover this distance, this particular distance with this particular time, with this particular speed? What is the average distance covered by the car? What is the average work done? What is the average power? What is the instantaneous power? What is the instantaneous energy? What is the average energy? So like this. Okay, this big changes and small changes. So where we are using calculus, where we are using actually differentiation and integration, I'll be saying you now, these small changes are generally are represented by letter D in front of the word, and these big changes are represented by letter delta. Okay, averages are represented by delta, and instantaneous values are represented by a small letter D. Okay, a small letter D. Okay, clear? Are we good to go? Yeah. So when we are moving from small changes towards big changes, you take very small changes and you want to add them up. And you want to create a big change. Then you have to use the very required concept of integration. Very required concept of integration. The integration literal word meaning is to sum up. When you want to sum up or merge very small values into a big value, then you have to use integration. But you don't want to sum up, you do not want to sum up, you want to convert this big change into small changes. You want to break it down, in order to make your physics very easy. So then use differentiation. Okay, differentiation. What is differentiation? Breaking down. What is integration? Summing up. Clear? I'll be let me just give you more clarity on this. Let me just give you a more clarity on this. A bit clarity is required for you on this. If this is a line, for say, for suppose, and I want to, if this is a length of 10-meter line, and I want to mark readings on this. I want to mark readings at sorry, not meters, say centimeters. Say centimeters. I want to mark readings of 1 centimeter each. I have 1 centimeter gap on this scale. What I do, I divide this. Right? So if from here, if I start from 0, this would be 1, this would be 2, this would be 3, this would be 4, this would be 5. What I am doing, I am differentiating this whole big line into small lines. And if I want to calculate anything, either it is a speed, either it is a time, either it is you can take the Ampere circular law, or Ampere circular law, and also you can take the Biot-Savart's law, in which we generally calculate the magnetic field intensity. So those all applied by this small current carrying conductor at a point P. On this whole current carrying conductor, if you want to calculate as per Biot-Savart's law, we generally break it and we calculate for dl length. What is dl length? D means very small, very small. What is delta L? Very big. So for dl length, we generally calculate the magnetic field intensity or magnetic field B. Am I right? Am I right? Yeah. So like that you can calculate anything using this small piece. And it is very interesting that the characters which are exhibited by this small piece only are exhibited throughout the length of the wire. Are exhibited throughout the length of the wire. Okay, let me just check whether the video is recording and everything is fine. Yeah, throughout the length of the wire, or throughout the length of this line, you will be having the characters which are processed by this piece only this piece, and they will be repeating. You can calculate for any such pieces, any such piece, and you can just add them like this. Okay, you can just add them. When you are calculating a small piece, where you have divided the whole length of the wire into small pieces, and you use differentiation in order to calculate this value of this small piece. And when you want to sum up all the small pieces, and you want to calculate the thing or value for this whole wire, you use integration. So this is the very basic introduction of calculus. Now we are going to study the differentiation part in today's video. We are going to study the differentiation part in today's video. Okay, yeah, video will be long. Please just bear with me. Video will be long. Okay, yeah. Put the heading differential calculus. Okay, let's just wait. Let me just change the brush. This is so. Yeah, this is fine. Differential calculus or differentiation. Yeah, put this main heading, and now we will be starting with the notion or denotion. Okay, simply you can say notion, notion, notion and meaning. We have already discussed about the meaning. Yeah, until now I have told you the meaning. Now we will be seeing the notion of this differentiation. How will you represent this differentiation? The notion is very simple. You put dy by dx. Okay, wait a minute, sorry. You put dy by dx. Okay, dy by dx. What are these? Yeah, what are these? This is nothing but this represents rate of change of y with respect to x. Rate of change of y with respect to x. How are you representing this? Let me just clarify you that if you say, for suppose, y is the function of x, some function of x, y is some function of x. That means y value depends upon x. Am I right? Y value is depending upon x. So when you are changing x, y is also changing. You can put any value of x, and that value represents y, and that value indicates the y. So the rate of y is changing as per the x. So you can simply, in our small classes, in our smaller ninth and 10th classes, you have learned that. You have learned solving some simple equations like 2x plus 5y is equals to some 9. Yeah, 2x plus 5y is equals to some 9. What I have to do, if I want to plot a graph, what I am doing in, what I did in my earlier classes, what I did is I want to solve for y. I have the values of x, I want to put my own values of x, so I would put like this. Sorry, I would put like this. Am I right or wrong? Y is equals to 9 minus 2x by 5. And what is this? What is this? Y is a function of x. It is simply that it does mean y is a function of x. Now, in order to find the what I do, I put x, I put y. In order to plot a graph, I draw a table. I draw a table. I put value of x as 1, and I calculate value of y. What would be the value of y if x is 1? 1, 7 by 5. If x is 2, if I put 2, 4, 5 by 5, 1. Am I right? Am I right or wrong? 9 minus 2 into 2 by 5. What is this? This is 4. 9 minus 4 is 5. 5 by 5 is 1. Yeah? Yeah? If I put 3, 6, 3 by 5. So see, the values I'm changing for x. I'm changing for x. I'm not changing for y. I'm just changing for x. But the values of y are also changing with respect to x. With respect to x, the value of y is also changing. So that is why I call this as rate of change of y with respect to x. Very clear, very clear, very simple. Whenever you find this, wherever you find this type of notation, you just simply say it is a rate of change of numerator with respect to the denominator. Denominator. Here I want to introduce two words to you. You know these words: dependent variable and independent variable. Okay, I'm just taking off this. It is not required now. Okay, wait a minute, wait a minute. I require this, that part. I just only require this. Okay, okay. I have to just introduce two terms to you. That is dependent variable and independent variable. I am telling you the notion and how to understand the meaning of this simple notion. This is a not notion. Generally, this is the notion. How we represent this, how we denote this differentiation, how we generally denote this differentiation. And now I am explaining you how to analyze this and how to convert based on your requirement. I am telling you this. I am teaching you that. Okay. Yeah. Okay. This part is not visible to you. What's happening? Okay, this one. Okay, dependent variable and independent variable. What are these two? See, see in this equation which I have written here, y as function of x. What I am doing? I am changing the values of x. If I am changing the values of x, y is changing with respect to x. So who is dependent on whom? Y value is dependent on x value. Simple, simple. What is meant by independent? Independent means it does not depend on anything. What are you saying, sir? It is simple. See, independent means the value of that, so some sort of the independent variable cannot be affected by any other variable, is not affected by any other variable. If the value of x is not affected by any other variable, as per my wish I am changing the value of x, but At the same cost of time, if you take y, the value of y is being affected by x value, which I am changing on my own. So the variable which is independent or variable which is unaffected due to the presence of other variable is called as independent variable. Here independent variable is x. It is remaining intact if I whether it is remaining intact due to the presence of y. It is not getting anything due to the presence of y. But y is the dependent variable. See, if I'm changing the value of x, value of y is also changing. If I'm changing the value of x, value of y is also changing. So that is why y is dependent and x is independent. So I can also write the above written equation or above written words or sentence as following. This differentiation is also can be written as rate of change of a dependent variable with respect to WRT, means with respect to independent variable. Okay, dependent and independent variable. Very clear. Very clear, these two, dependent and independent variables. Now I can also write this as, it is the rate of change of numerator. I'll be giving you examples in the next slide. Wait a minute. Rate of change of numerator with respect to denominator. Rate of change of numerator with respect to denominator. I can also write as differentiation of y with respect to x. Very clear. It is also written as differentiation of y with respect to x. I can also write it as derivative of y. Y is derivative of x, right? Of y. Derivative of y with respect to x. So these are the things. Whenever you see this type of notation, you can simply call it as, it is either rate of change of x y with respect to x. It is either rate of change of dependent variable with respect to independent variable. It is also called as rate of change of numerator with respect to denominator. It is also called as differentiation of y with respect to x. It is also called as derivative of y with respect to x. So these are the things that you have to know. It is very simple, very clear, very understandable. You have to know this very basic things. Okay, these are the different forms in which you can call the above written notation. Okay, the above written notation of this thing, like you can say the differentiation, you can call these ways. Okay, that clear? Am I good to move? This is the previous page, this is the this page, second page, and we are moving on to now for some small examples. For some examples I wanted to give you for the above written notation. We have written notation, right? We have written notation, that is dy by dx. For this I am giving you some examples on this page. Okay, examples on this page. Yeah, examples on this page. For example, when we go to use of this differentiation in kinematics, either it is straight line motion or plane motion in a plane. I'm just taking straight line motion thing. So in that we say that change of position with respect to time. Okay, change in position is called, generally I'm telling, is called displacement, right? Change in position is called displacement, and this change in position, if it is this change in position with respect to time, this is called as speed. Yeah, change in position with respect to time is called as speed. So what can I write? Change in position with respect to time, for say suppose position is denoted by x, then I can write as dx by dt, and this dx by dt gives you a v, velocity or speed. Okay, it is not speed, sorry. We are changing position as displacement, so we have to use velocity. It is velocity. Yeah, dx by dt is velocity. What is this? What can all you can call this? It is you can say change in position with respect to time, or differentiation of x with respect to time, or derivative of x with respect to time, or you can also say that, you can also say rate of change of dependent variable, that is position, with respect to time, is also your velocity. Clear? Clear? Now rate of change of this velocity, rate of change of this very velocity, not very, sorry, rate of change of this velocity with the time. Okay, rate of change of dv by dt gives you acceleration. Rate of change of velocity with the time is acceleration. Yeah, rate of change of position with the time is velocity, and rate of change of velocity with acceleration with time is acceleration, and therefore you can say it is the double differentiation of change in position which gives acceleration. Here it is differentiation of position with respect to time is velocity, and differentiation of velocity with respect to time is acceleration, and therefore I'm calling it as double displacement, and this such kinds of things is called as successive derivatives, and such kind of things is called as successive derivatives. Sorry, 1 minute, let me just remove these. Yeah, yeah, I'll be talking about them in the next slide. Wait a minute. So this is the thing. This is the some examples. These are some examples of the above notation. Okay, very clear. Now, in the next slide, I am telling you successive derivatives. Some sort of artistic works. Just wait a minute. Just put off it aside. Okay, successive derivatives. What are these successive derivatives? In the previous slide I have told you that it is the rate of change of position with respect to time that gives you velocity. It is that rate of change of velocity with respect to time gives you acceleration. So that is why I'm writing here with a simple notation, with a simple form of in a simple form of equation, that x gives v and gives a, yeah, all are vectors. I'll be taking you a separate class on vectors also. It includes in this basic mathematics only, please do not worry. Well, you're going from position towards acceleration, that gives that you have to use differentiation. when you are moving from change in position towards acceleration, you have to use differentiation. So this x, okay, differentiation, you remember, do you remember this equation which I have told you this? So for differentiation, if you have to say that function which we are applying for x, which gives you, which results in the value of y, for if it is differentiation, you can put a dash. If it is single differentiation, if it is double differentiation, two dashes. If it is triple differentiation, three dashes, so on and so forth. Now, when you want to find acceleration from this position, when you have a position change in position, x is given to you, small change in position, x is given to you as some value, and you want to find this acceleration, then you have to use double differentiation. Okay, double differentiation. Yeah, sorry, you have to use double differentiation here. But if you have already but if you want to find the value of v velocity with having change in position, you have to only use single differentiation, which we have already learned. If you want to find the value of acceleration with respect to this velocity, you have to use single differentiation. So this is about the successive derivatives, and I can also extend this to jerk and from their impulsion, etc., etc. No need for argument. Okay, now I want to just tell you something which is regarding the Newton's second law of motion. Okay, I want to say you this. As per Newton's second law of motion, as per this, as per this, you can say that, 1 minute, yeah. A rate of change of linear momentum, rate of change of linear momentum with respect to time gives you force. How can you represent this? dp bar by dt gives you f bar. dt bar by dp bar by dt gives you f bar. It is a rate of change of linear momentum with respect to time gives you force. Yeah, so like that, if you also want to find force using this momentum, you use differentiation. But if you want to find momentum using this force, you use integration. Integration is a reverse operation of differentiation. Simple. Okay, if you want to find a force from a momentum, you use simply differentiation. But if you want to find a momentum from force, you use integration. These two are opposite in functions. Okay, very clear, very clear. These are the basic concepts. Now I'm gonna give you some basic 11 formulas which are used in this differentiation. While differentiating, if you remember these formulas, it becomes very easy. Basic formulae. There are 11, 12 formulae. There are totally 12 formulae. 11 only, 11 only. 11 formulae. Please learn these 11 formulae. What is happening at all? 11 formula. The first formula, I am generally representing it these all formulas in this form. These all formulas in this form. Okay, look here. Y is equals to f of x. I am representing in this form, general form. Okay, and these derivatives I am representing as dy by dx. Okay, clear? or you can also say it as f dash x. I am representing these derivatives on the right hand side and the basic general equations and basic general terms on the left hand side. When I start writing, you will be understanding them. No need to worry. Yeah, no need to. Extremely sorry, guys. I'm just yawning in front of you. Yeah. If the form is in the form, if the given thing, if the given term is in the form of x to the power n, x to the power n, then its derivative, then its derivative would be something I'm representing with the t, just not okay. Okay, this is just representative of derivative. It is not this, it is just representative of derivative. Or I can wait a minute again, why to confuse you. If the thing, if the given item is in the form of x to the power n, then its derivative, then its derivative will be nx to the power n minus 1. The thing you have to do is, you take that power which is given n, you multiply with x, you multiply x with that power, and then power you just reduce by 1, you get this. If it is x square, then it becomes 2x to the power 2 minus 1, which is 2x. If it is x cube, it becomes 3x to the power 3 minus 1, which becomes 3x square. If it is x power 4, then it becomes 4x to the power 3. Yeah, 4x to the power 4 minus 1, which gives you 4x cube. If it is x power 5, it gives you 5x, sorry, not 2, 5x to the power 5 minus 1, which is 5x to the power 4. So this is the very basic first form. Got it? Solve for x to the power 10. Solve for this and tell me now. 10x to the power 9 is your answer. Okay, very clear. We have done with the first very basic formula. What is it? I'm writing the previous page formula on this page also. Okay, x power n, you will write simply nx to the power n minus 1. If it is like this, a to the power x, if this x is in the power form, if this x is in exponential form, so this one, if it is in power to some other constant, then it becomes log of, or you can say simple natural log of a to the power x ln a to the power x ln a. ln means it is natural logarithm. Natural log. I'll be talking about logarithms in the separate video. So logarithms. Okay, logs simply. It is natural log. So when I want to write, I'm giving you examples also parallelly. If it is some say 10 to the power x, then you get then its derivative would be 10 to the power x ln 10. It is also write as log base to log log 10 to the base e, which is 1. Okay, no, if it is like 2 to the power x, 2 to the power x, then 2 to the power x ln 2, if it is 3 to the power x, it is 3 to the power x ln 3. Okay, if it is 5 to the power x, it is 5 to the power x ln 5. Clear? If it is some okay, calculate for 7 to the power x now. Fast. Yeah, this is your answer. Okay, clear with the second basic formula. Let us move on. The first very basic formula we have learned is this one. The next very basic formula we have learned is this one. Okay, these are this way which I am writing. These are the formulas from your previous pages. Okay, previous pages. Keep on looking at them. Keep okay. I hope there is my camera. Yeah. Sorry guys. That way is my camera. I'm just pulling it down. No problem. Yeah. No problem. No problem. No problem. Come on. Come on. Come on. Come on. No need to stop. I'll just pull this also down. Very good. We are very good to go. And now go. Now, the third very basic formula is basic formula is if it is e to the power x exponential form, then it becomes e to the power x only. Its derivative remains e to the power x only. Okay, this is your third very basic formula. Next, fourth formula, if it is a constant, the derivative of a constant is 0. There is no change at all in constant. Here, are you clear? If you have to write dx by dt, d means change, right? It means change. But if it is a constant, change is equals to 0. 0 by 0, which is equals to 0. Not 1 ray, 0 by 0. Not 0 by 0, it is generally 0 by dt. Sorry, 0 by dt is equals to 0. So that is what differentiation or derivative of a constant is always 0. No, don't worry, I'll be making you practice many examples now. After this, I'll be making you to practice many composite examples. I'll be telling you how to do. Okay, if the thing is like this, if it is in a form of ln x, then it will be 1 by x. Okay, 1 by x. If it is log x, then it will be 1 by x. Next one. Now we are moving on to trigonometric. Sin x, cos x. Derivative of sin x is cos x, but derivative of cos x is minus sin x. Okay, clear? Derivative of cos x is minus sin x. Next one, tan x, secant square x. If it is tan x, derivative of it is secant square x. If it is secant x, then it is secant x tan x. Okay, if it is cot x, then it is minus secant square x. But if it is cosecant square x, and if it is at all cosecant x, it will be minus cosecant square minus cosecant x and tan x, not tan cot. This is cot x. Okay, very clear. These are the 11 very basic formulas. You have to learn. It is a mandatory. Okay, it is a mandatory. You have to learn all these 11 very basic formulas. Once just see about this. Once just take a look. I'll be moving on to the further examples. Now practice and practice. Now the thing is, practice makes man perfect. I'm just putting these also the side so that you will be taking a look at them also. These are in the previous slides. Take a look at them also. Okay, have a look at all of these. We'll be now doing the sums. Clear? Can I move to the second page? Just pause the video and take a look at these 11 very basic formulas. They will be helping you, and I'll be showing you how to use them in our examples. Okay, can I move? Now let us just practice some of the formulas, some of these examples. Okay, not formulas, some examples. Now y is equals to 3x cube Do the derivative. Find the dy by dx. It will be, find it, find it. It is very simple. It is in the form of x to the power n, x to the power n. If it see if at all the variable is containing a constant as a multiple or a coefficient is a constant, then this coefficient just simply slips away or slips out from either you can say differentiation or integration. If it is either integration or differentiation, in both the cases this coefficient slips away from the differentiation. You will not integrate or differentiate this coefficient, simply you just ignore it and do the differentiation of this variable. Now it is in the form of x to the power n, which results in nx to the power n minus 1. So it is 3 into 3 x to the power 3 minus 1, which is 9x square. Okay, it is a 9x square. Now, if y is equals to root x, find the derivative of this. Y is equals to root x. Yeah, root can be written as to the power 1 by 2 to the power half. So from that dy by dx becomes half x to the power half minus 1, which gives you half x to the power minus 1. If anything is in the power of minus 1, you can just reciprocate it like this, 1 by 2x. Am I right? Am I right? Am I right? Sorry, it is minus half. Minus half. So half then implies 2 1 by 2 root x. Am I right? Very clear? Yeah, very clear. Next one. If y is equals to 1 by x square, find this. If y is equals to 1 by x square, find the dy by dx. Y. If this y is equals to 1 by x square, find the dy by dx. This can be simply written as x to the power minus 2. Yeah, x to the power minus 2 and then minus 2 x to the power minus 1 minus 2 minus 1. Then it becomes minus 2 to the power minus 3, which gives you minus 2 by 3 x cube. Yeah, minus 2 by x cube. Got it? Got these three? Got these three? Remember this. Remember this. Do not try to derive them. Remember this. If y is a function of, if y is equals to root of x, then its derivative dy by dx is 1 by 2 root x. Remember this. Remember this, it is enough. 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 Okay. Do not try to foolishly derive that in the presence in the examination hall. Okay, clear? Yeah. So now let me give you some basic rules. Basic rules in differentiation. While differentiating, basic rules while differentiation. The first one, if at all you have to differentiate an equation which is containing addition or subtraction, then you simply differentiate the individual terms and then put the sign which is there. If y is equals to f of x plus or minus g of x, it is either in addition or subtraction, no problem. Now you have to do is just differentiate this f of x first, then differentiate the g of x, then put the sign and mix them together. Now if it is differentiation, then it's dy by dx becomes f dash x plus or minus g dash x. Okay, clear? This is the This is the differentiation when this is how you have to do the differentiation when they are in addition or subtraction. Clear? Now we'll be moving on to the product rule. What is product rule when it is in multiplication? When it is in multiplication like this, if y is equals to f of x dot g of x, then you have to do is, then you have to, what you have to do is, you have to differentiate first this and remind this as it is, put a plus, then differentiate this and put this as it is in multiplication. So you have to do, first you have to differentiate this like this and put this g of x like that intact, and then differentiate g of x like this and put this intact f of x, and you get your differentiation result. Is this clear? Is this clear? Is this clear for all of you? Is this clear? Yeah, let us move on. If it now you have to discuss about quotient rule, or if it is in division, or division, how to do. If it is in division, how can you solve it? If it is in division, how can you solve it? Wait a minute, just I'm seeing what is the time. Division. If it is in division, how to do it? If it is in division like this, y is equals to f of x by g of x. Listen to this very carefully. It is a little difficult, but it is very simple when I tell you. It becomes very simple. Do not fear of this. Do not fear of this. Very simple. Denominator का square and denominator. Okay, gfx का square in denominator, and numerator, first of all differentiate numerator, and put this g of x simply like that, in the same as you did in the multiplication, but you have put plus there, now put minus here. हो गया, put plus, you have put plus here, put minus and do denominator का square. Very clear? Very clear? The next very simple rule, it is called as chain rule. Oh, sorry. Chain rule. Chain. What is happening to this today? Wait. Hey. Okay. Chain rule. Chain. What is chain? It is like this: link to link, link to link. So if you get any composite functions, if it is composite function, like if you have one function inside of the other function, if you have another function inside of these two functions, then you do what, you know, you go from outside to inside, you just break one and you finish one by one. One by one is a simple trick for this chain rule. One by one, go one by one, go one by one. Clear? Clear? No. Yeah, I'll be giving you some examples, then we'll be moving on to kinematics question. Then we'll be doing kinematic questions. Okay, now write this example: if y is equals to sin x plus cos x, dy by dx, find dy by dx fast. You have to be very quick. It is cos x minus sin x. Yeah, you know, the derivative of sin x is cos x, but derivative of cos x is minus sin x. So that's it, completed. Right? So as per the formula, as per the basic rule, you do like this, but then plus of minus will be minus. So I have written it very simply in a general form. Okay, what you have to do, using the basic formula, how do you do is this? See, You do it like this. You generally differentiate first of all f dash x. You generally differentiate f of x first. It is in the form of like this only now. Y is equals to f of x plus g of x, multiplication, sorry, addition and subtraction. Then what you do, you find for finding dy by dx, you do differentiate the f first of all, f of x first of all, then g of x, and then put the sign which is there. Here it is addition, so I put plus. If it is a subtraction, you put minus. So simply first of all differentiate f of x. If you differentiate f of x, here f of x is sin x, so if you differentiate it, you get cos x. I have given you this. Then you put plus, and if you now differentiate g of x, if you differentiate g of x, which is cos x, you get minus sin x. So plus of minus is minus. So that's what I have written. Okay, clear, clear, clear your doubts, cleared your doubts. If you have any doubt, please post it in the comment section below without any hesitation. I'll be just trying to recall it. Okay. Next question. Next question. Y is equals to e to the power x dy by dx. I want dy by dx very fast. This is very quick. Same. No problem. No problem. Now coming big composite function x cube plus 5x square plus 3. Differentiate this. Find dy by dx. Do not worry seeing this whole thing. Do not worry. It is the very basic rule. First one, addition rule. Do that. Okay. Now it comes 3x square plus 10x plus 0, which is 3x square plus 10x. Have you got this answer? Everybody, have you got this answer? Yeah. Why have I put the 0 here? Constant. This is a constant. This is a constant. This is a constant. So 0. Now, first let us take another example. If y is equals to, do this. If y is equals to root x plus x square plus take x to the power minus 2. Solve this equation. First of all, what you have to do? It is very simple. Do not worry. Convert it into your favorite form. Okay, convert it into your favorite form. How's it? Do this. Simply do this. Yeah. Now differentiate dy by dx. Now sorry, why I have put this? Now differentiate dy by dx becomes, first of all, fast. Everybody, come on. Do it. Do not stop. Oh shit. I have told to remember this, right? Why? Minus 2x cube. So this is this. Clear? Very clear. These are the equations, and this is differentiation. See how simple it is. And how funny it is. I'll be giving you some equations. Just practice for home. Practice at home if you are free. You can only on yourself. You can create these equations. See, I'm just creating these equations like that. I'm not doing anything. New. Give to your brother or sister who is studying, and just let them write any nonsense equation, and you try to differentiate that one. I'm giving you, right? See, this is some nonsense equation which I'm giving you. There is no sense in this, but I'm giving you this. Try these two now itself. No need homework, no need thing. Do not carry things to home, guys. Let us try here. Let us try this. Fast. Who will be telling me the answer first? Okay, have you done? Have you done? Have you done? Completed? Yeah. We have to be very quick. Okay, okay. For those people, let me just. Oh yeah, timer is there. Let me just give you some time. Okay, it is milliseconds. Sorry. What is this? Okay, got it. Hours, minutes, and seconds right here. 10 seconds timer. Do it. 10 seconds. Do it. Solve this. Yeah. Have you ever solved it? Yeah. Wait a minute. Yeah. Yeah. Let me solve. Let me solve for you. First equation dy by dx becomes 5x to the power 4 plus 12x 12x plus 3 plus 0. Yeah, 0 eliminated. The second equation becomes dy by dx becomes 42x to the power 5 plus this is this one. Am I right? Minus. Yeah, wait a minute, guys. It is minus, right? No, no, plus only. Plus. Sorry. I just got a confusion, a little confusion. Now here minus comes. Minus 2 to the power by x to the power 3 plus 0. Finished. 10 seconds. 10 seconds. Completed. Now, let us solve some of the very basic kinematic questions. Kinematics questions. Question number 1. If two cars, I am declaring a question, I am not writing it, I am just mentioning the important things. If two cars P and Q, there are two cars P and Q. Okay, I am declaring the question, please write it, please write it, no need to draw cars, no. If there are two cars P and Q, start from a point, at the same time, their positions are represented as xp. Position of p is equals to at plus bt square, and position of q is represented as ft minus t square, 2t square, or simply 2t. Sorry, take t square, quadratic equation, right? Yeah. At what time do the cars have same velocity? Vp is equals to Vq. And at what time they're asking you to find the time? Very simple. Very simple. Go back to the page where I taught you successive derivatives. Go back there. Yeah, see this. Oh, yeah, here it is. Here it is. Very simple. Let us do this. Let us do this. From position to velocity to acceleration. Yeah, from position to velocity to acceleration. Now first of all, let us differentiate this xp to find velocity. If we just equate these velocities, our work is done. If we try to equate these velocities, our work is done. In order to find the velocity of xp, p, what you do? Car p, what you do? You differentiate it. You differentiate this equation. When you differentiate, what is it? A plus 2bt. Yeah, a plus 2bt. This is the velocity of p. Okay, now velocity of q, which is equals to dxq by dt. Find it. F minus 2t, now we equate these two. In the next page. No, this page only I'll use. Equate these two. Yeah, equate them. Equate these two. Vp is equals to Vq. They have given you the question in the question. Yeah. Now find d. Put this 2 minus 2t here and a here. 2bt plus 2t gives you f minus a. Taking 2t common, taking out 2t common, it gives you b plus a, which is equals to f minus a. Now if you send a t is equals to f minus a by 2 into b plus 1. This is the answer. This is the answer. This is the time at which the velocities of both the cars will become equal. Velocity of both the cars will become equal. Okay, ready for the next question? Ready for the next question? Very simple. Very simple. Let us move on to the next question. Let us move on to the next question. Yeah, we have used 19 pages. Let us delete these. Delete and this one. Wait a minute, guys. Just I'm gonna delete these two. This one and this one. I'll be adding one by one. Why tension? Why tension, right? Why tension? Yeah. Now let us do the second question. Second kinematic question. Isn't there very easy? The position of x, the position x of a particle varies with the time. Varies with the time. Position is varying with the time. Position is varying with the time as x is equals to at square minus bt cube. The acceleration at a time t of the particle will be 0. Acceleration is 0 at what time? Find t. At what time its acceleration will be 0. Now go to the successive derivatives. I have given you this simply. They have given us position. You have to double differentiate it in order to get acceleration. Yeah, you have to double differentiate that in order to get acceleration. So what do you write here? Dx by dt. Yeah, d square x. You for double differentiation. I haven't given you the notion there. I'm telling you this. If you have to, in case you have to solve for double differentiation, you do like this. This is the representation of double differentiation. Gives you acceleration. For double differentiating, just this. Do not get panic. Just you have to do is first differentiate the given equation once. Okay, that's all we do not require. We require only our equation. Yeah, that also I'll be moving up a bit. Oh, what is this? Yeah. Now for double differentiating, do not worry. First find dx by dt one time. Then again do the dx by dt. Solve it for that. Yeah. Now again differentiate it. Again differentiate it. Now they have, this gives you acceleration. They have given in the question that acceleration will be 0. So 0 is equal to, equate this to 0. You will be getting time. Find this t. Take this to there. Then will be 2a is equals to 6bt. T is equals to a by 3b. Am I right? 2a by 6b. 2 mar gaya. 2 by 6 means 1 by 3, which gives you a by 3b. T is equals to a by 3b. At this time, at this very particular moment, acceleration of that particle, very particle, will be 0. Okay, clear? Clear? Super. Now let us solve another question. Let me just check how many minutes it has. Minutes or hours? Wow, it is 1 hour 14 minutes, and we are gonna complete differentiation within 1 or 2 questions. Okay. Okay, let us go take a break. If you want, pause the video and take a break. I'll not take a break. I'm recording the full stretched video. I'm not stopping it anywhere. I'm recording the full stretched video. Okay. Now, motion of a particle motion of a particle along a straight line is described by the equation x is equals to 8 plus 12 t cube. Okay. Okay, where x is in meters and t is in seconds. The retardation of the particle when the velocity is 0. Very correct question. Very good question. Very good question. They are asking you retardation. What is retardation? They are asking you retardation. What is this retardation? It is negative of acceleration. Negative of acceleration. Very clear. Retardation is negative of acceleration. So if we find acceleration, then we find retardation. It is very clear. Okay. Now, what to do to find acceleration? They have given you a small hint that velocity is 0. Then find time with this clue. You will be nailing the question. How to find velocity? First of all, differentiate it. It is 36 t square, right? 36 t square, and this is velocity and this is 0. 0 is equals to 36 t square, t is equals to 0. Am I right? If t is equals to 0, if t is equals to 0, acceleration is also equals to 0. Yeah, yeah. How acceleration is dv by dt? We have got v as this. Now differentiate this. How much you get? 2 172 t. Acceleration is equal to 72 t, but t is equals to 0, so acceleration is equals to 0. Acceleration is equals to 0. Okay, clear? Clear? One last question, guys. One last question. One very simple last question. Okay, one very last question. A particle moves along a straight line such that its displacement at any time t is given by s is equals to t cube minus 6t square plus 3t plus 4. The velocity when the acceleration is 0. They are asking you to find velocity when acceleration is equals to. Wow, very superb question. Again, a very superb question. Very superb, very superb question. Yeah, yeah. Now, first of all, find ds by dt, you'll be getting velocity. Yeah, they have given you acceleration is 0. So, double differentiation of displacement is 0. Double displacement of different displacement gives you acceleration, and that is 0. So, this is equals to 0. So, first of all, find the double differentiation. So, in order to find it, do like this. Why to waste your time, Rababu? Do it like this. This is 0. Now take this 12 here. T is equals to 12 by 6, which is a 2. T is equals to 2. Now put this T is equals to 2 here, since velocity equation is this. So 3 square, 3t square. So T is equals to 2 we got. T is equals to 2. So what you have to do, put 2 here. So now 3t square, 2 square 4 through 12 minus here 2 24, yeah, plus 3 minus 12 plus 12 minus 24 is minus 12 plus 3, which is equals to 9, minus 9. minus 9 is your velocity, minus 9 meter per second. At this velocity, with this velocity, the particle is moving when its acceleration is 0. Okay, right? Yeah, these are some questions on differentiation with the kinematics which we have solved today. So thank you guys. This is Vamsi signing off, and hats off to your work. You have you know nearly you have you sat at one place and nearly you have listened this lecture, this like big lecture, like from 1 hour 20 minutes you are been listening this lecture. You have been practicing with me, you have been working hard. So work hard like this. I'll be back with the integral calculus also, and then we'll be moving on to vectors. Integral calculus is very simple. Here you have only 6 basic formulas, but in differential calculus you have follow basic formulas. Here you have only 6 basic formulas. It is very simple. I'll be teaching you in the next lecture. After that, we'll be moving on to vectors, which is very favorite topic of us. Yeah, vectors is vectors very favorite topic. If you think vectors is very, big and very tough, no problem. I'll be making you easy. After vectors, we'll be completing our basic mathematics. Then we will be moving on to the original uh, lessons. Original lessons for NEET, that is units and dimensions, motion, kinematics simply. After that, we'll be moving on. We'll be extending our syllabus. Okay, guys, this is Ramzi signing off. Have you a great day further, guys. Thanks for watching. Bye bye.